Welcome back. In this video, we're going to look at base-promoted alpha halogenation. So what we're going to do in this reaction and mechanism, we're going to be having a reaction happen at the alpha carbon again, and but we're going to change our electrophile. In the previous video, our electrophile was an alkyl halide. In this video, it's going to be a halogen. So I2 or Br2 or Cl2. And what's going to happen is we're going to start with a hydroxide base here. That's going to deprotonate our alpha carbon, so that's a proton transfer. Okay, and that makes our enolate ion. This is one resonance form of the enolate ion. We could have another resonance form where the negative charge is on the oxygen. And then this can react with Br2. And this is a strong electrophile. We've seen this react with alkenes before. We've seen it involved in bromination of an aromatic compound. Okay, it would form a complex with FeBr3. Okay, but we're going to use it to react with this carbon here. Okay, like so, and this is an SN2 type step. And this gives us an alpha brominated ketone. Now, this reaction usually doesn't stop here, because now with this bromine here, this hydrogen has become even more acidic, because if we have a negative charge here, it can be stabilized by a bromine, which withdraws electron density. And so this is likely going to continue on until all those alpha hydrogens on that carbon are gone. Okay, and so this forms the basis of what's known as the haloform reaction. And so I'm going to go over that reaction. Oops. Haloform reaction. So haloform could be chloroform or bromoform or iodoform. This is one of the products of this reaction that we're going to see. And this will typically happen with methyl ketones, so I'll just use a really simple one. Acetone, and let's use Br2, and we're going to use excess of that, and then hydroxide. We'll do sodium hydroxide, and we'll probably have some water in there as a solvent or present. And what we end up getting ultimately is a carboxylate, all right, plus, in this case, bromoform, all right, CHBr3. Okay, so let's break that down a little bit as to what's going on. So we're taking, again, in terms of summarizing the transformation here, we're taking a methyl ketone, So a ketone that has a methyl group on at least one side, in this case it's got it on both sides, and we're turning it into a carboxylate. All right, now maybe we would want a carboxylic acid. We could add some acid to this, and then we would get the carboxylic acid. So this gives us a method taking a ketone to a carboxylic acid, and we're clipping off one carbon. Here we went from 3 to 2 carbons. Okay, but let me break down this reaction, the bromo or haloform reaction, a little bit. Okay. I'm not going to show all the mechanistic steps, but I'm going to break it down a little bit more, into a little bit more detail. Okay, so what's going to happen here is we've got Br2 and hydroxide, and we've got excess of the bromine. And so what's going to happen, we're going to do a proton transfer, we're going to deprotonate that, and then we're going to do an S on and 2 on Br2, and we're going to do that 3 times because we have 3 hydrogens there. All right, so multiple times here, and what that gets us to is this compound, where we have 3 bromines on the alpha carbon. Okay, and this is can act then as a leaving group because there's all these bromines on here. If we were to have a negative charge on that carbon, it would be somewhat stabilized. Normally, we don't like to propose carbanion leaving groups, but in this case, we can get away with it. Okay. So what can happen here is we can do a nucleophilic addition with our hydroxide. So up to this point, the hydroxide has been acting as a base, but it's going to act as a nucleophile at this point in the mechanism. Trying to think about my board management here. All right. So that gets us to this point. Got that CBr3 here. All right. Then this can leave in a nucleophile elimination step. And that is going to give us this intermediate. Where do I want to put that hydrogen? I'm going to put it right here. Okay, and I'm going to put the CBr3 here. Okay. Add some lone pairs on these bromines. Try to. Okay. All right, this is, carbanions are usually not happy, just hanging out, but with these 3 bromines, that kind of stabilizes that negative charge. But this is going to react quickly now to do a proton transfer. And I'm going to have to erase this now. All right. Proton transfer. And that will get me to my carboxylate. Plus bromoform. Plus. All right. So that's going to conclude this lecture on base-promoted alpha halogenation and the haloform reaction. Note, it's called base-promoted because we use a full equivalent of the base when we're doing that alpha halogenated. So it doesn't get regenerated, so we don't call it base catalyzed. All right, thanks for watching.